log file architecture. So this should be discussed in database architecture, our second topic. I wantedly kept on moving further and further. So we wantedly delayed to discuss this topic because it is related to database backups and restores. So if you know transaction log architecture, you will understand backups and restore perfectly. That is why we have not discussed this topic on database architecture. Okay, so if you see database architecture, I'll remind you one more time. So this is, if you feel, okay, just assume this is database. This is a database. Okay, so under database, we can find what? File groups. So then we can find log file. This is file group. So, okay, this is log file. So for log file, we don't have any file groups. Under file groups, we can find MDF, NDF. Under MDF, we can find extents. Okay, under extents, we can have what? What are the things? Pages. Very good. The fundamental storage unit of SQL Server are pages. So all this is, we have discussed all this left-hand part. So we discussed pages, extents. Okay, we have data file MDF and NDF. All these things discussed, but we ignored log file in database architecture. So now we will discuss how log file look like. See, in MDF, we have already discussed it. There might be extents and pages deep inside it, but how log file look like and what is the importance of log file? Thus, that topic we will discuss today. Fine, let's come to here. So before we discussing log file architecture, we need to know, so what are we logging in SQL Server and what are transactions and what are statements? Okay, so in any computer language, so you might be listening these words: DDL, DML, DCL. These are the important things in computer language. DDL language, DML language, DCL language, like this. Okay, so DML means data manipulation. If data manipulations means what? If you want, for example, there is existing information of Hari. You want to delete this Hari, that is data manipulation. You want to insert Hari, that is data manipulation. Or in place of Hari, you want to write Hari Kumar. So existing data, if you want to do inserts, deletes, and updates. If you want to do any of these operations, this is called data manipulation language. If you want to create a database or if you want to create a table, that is called data definition language. Okay, DDL means data definition language. DML means manipulation language. So under definition, we use create, drop, alter these statements, I mean commands. Under manipulation, we use insert, update, delete. So SQL Server supports DDL, DML, and DCL, DCL. DCL means data control language. DCL means transaction control language. So all keywords used in DML are here. I'm showing. So you can find in any language, these keywords are used. Okay. So by using these keywords, we will change data in database. For example, I have a table. So in the table, I have columns like this: serial number, name, location. Okay. If it is student database, then subject. So if I want to insert any data or delete any data, or I want to do anything in the table, I need to use one of these statements. Am I correct?
Yes, sir.
Okay. So whenever you use these keywords, Those keywords are helping you to create transactions. For example, if you want to insert some data in the table, so you write insert into, okay, table name, then values, one comma. So like this, you'll enter data. So this is called as a statement. Okay. So either one statement or combination of multiple statement, we call as a transaction. So transactions means what? For example, there is a table. In that table, 10,000 is the value. So you want to make it as a 5,000. Then again, you want to add two more thousand. Okay. So here you need to write two statements. One statement is, so, okay, decrease 5,000 from I62. I62 means this cell. Okay. From that, add 2,000 more to I62. So you are doing two transactions. I mean, two statements you are writing, but it is considered as a single transaction. So finally, you want to get this result, 5,000 plus 2,000, that is 7,000. So to get complete result, how many statements you are using? All the statements including, we call it as a single transaction. Is it clear? In a transaction, you may have multiple statements. I'll explain you better position in the better way. Give me 2 minutes. Okay. So anything fundamental key thing in database is whatever you want to write a database. For example, I want to add something to database. You cannot directly do changes to data file. So whatever you want to do, first you need to update all these transactions on log file. Did you remember this thing?
Yes.
Okay, this is called as val concept. Val means write, hide, log. So anything if you want to do changes to data file, the transaction first you should update in log file, then only it will be applicable into data file. That is concept. That concept is called as write ahead logging. Okay. So there are two types of transactions. One transaction we call it as implicit. Another transaction we call it as explicit. Let me explain what is the difference between implicit transaction and explicit transaction. Uh, go to database, go to GauravDB. Where is it? Here it is. Go to any table. So open customers. Okay, I'll take orders table because it has fewer columns. And what about products? Fine. So we have 10 products here. So I want to insert one more product. What is the statement? We use insert into
Into
values, insert into table name.
table name, then values.
Table name is products, values. So values 11 is the product ID. Then let's assume we are thinking about smartphone. We have already. TV, yes, we have it. Okay, let's think about bike. So this is bike and category. Category is transport. It is a sample data. So quantity in star, let's assume we have 20. So if I write like this is called as a transaction. It is a statement, but we want to insert only one row. So this is called as a single transaction. Okay. If we don't mention anything, for example, begin. Begin means you are starting the transaction. Commit. Commit means you are ending the transaction. So whenever you mention commit, that means the transaction is completed. Until unless you mention commit, the transactions will not complete. Okay, so still the transaction is pending transaction. Okay, so in SQL Server, in any other database, for example, like SAP SQL Anywhere, or in some type of other databases, you need to 100% mention commit after each statement. If you don't mention, what happens? Transactions is not completed. Let me show you how. So begin. Okay, I'm inserting this. Let me execute this. Done. Okay. What is the error here? This is integer. Fine. Again. So insert into products, values. Let me check product table one more time. 11, fine. By category. Price we haven't mentioned. So we need to mention price here. Let's assume this is 1.5 lakh. Done.
The price, we don't have that single number.
Yes, correct. This is also number. Again, the same issue. Product name, fine. Category, amount. So let's ask ChatGPT. Correct this. Copy this. Paste over here. It is not required. So what is the difference between this statement and that statement?
In the end, the semicolon is there.
Semicolon. Actually, it is not required. Fine. Now it is happened. Okay. So let me insert one more record here. 11th record already inserted. See here, 11th record inserted. So I'll insert 12th record now. So I mentioned begin statement. I have not mentioned commit statement. Okay. So now let me insert this. So why are we facing this issue again and again? Okay.
That is 11 again. You are
Begin tran, I think. Sorry.
that is 11. That
Now
product ID.
no, it is fine. It is fine. So begin tran, we need to mention begin transaction.
Okay.
That thing I missed. Okay. Now, what is the row inserted?
12.
12th row, right?
Hmm.
So let me query this 12th row from another table. I mean, another session. Okay. So I'll take another session. Select star from products, right? Execute this. So you cannot open the table. See here what is happening here. Let me make it little zoom. What's happening here?
Query is executing.
The query never completes because this transaction has not completed yet. Until unless you mention commit, so the transaction never completes. Okay, check here. So you can see 12th row record, right? So in the same session, you can see the value because you are the person modifying this. But if you take another session, you never read the table because the transaction has not completed. So let me execute this commit. Done. Now see, you can check the values. So commit means what? Commit means transaction completed. Okay. So here we have two types of transactions. One is called as explicit. So explicit transaction means whenever you write a record, you only mention begin tran and commit. So if we clearly mention, that is called as explicit transaction. Okay. So if I don't mention anything, okay, this is called implicit transaction. So under implicit transactions, if we don't mention begin, tran, and commit, by default, SQL Server will automatically uses begin, tran, and commit after each statement. Before each statement and after each statement, SQL Server automatically puts begin, tran, and commit. So that is why until now, we never mentioned begin, tran, and commit whenever we were creating tables or inserting values. So we never mentioned anything, but each statement was committing automatically with the help of SQL Server. So there are two types of transactions. One is implicit transactions, another is explicit transaction. If we don't mention begin, tran, and commit after transaction, okay, so SQL Server automatically assumes it needs to be mentioned begin, tran, and commit. It will do that. That is called as implicit transaction. Is it clear?
Mhm.
Commit
Yes.
means commit finalizes the transaction. If we don't mention commit, if you mention begin, tran, and forget about commit, then you cannot read the table with any another session, or any user outside of the session cannot see the table. Commit means what? Commit means you are telling to the table this change is permanent. Okay, so the change will be permanently written into the database. Once transaction is committed, you cannot delete. For example, so what I'll do is I'll insert one more record. So record is 14 and I'm not mentioning commit. Let me execute this. Done. Fine. So select star from products. Check this out. So how many? What is the last product ID?
14.
14. So by mistake, if I mention
Mhm.
rollback, or if I close this session, or if I shut down database, or I shut down instance, this change, whatever is not committed, will be rolled back. For example, let me execute rollback. Now check this. So this change is not permanent. You can't see 14th record. If you want to make it permanent, 100% you need to use commit. So if you use commit, then only we can say this change is permanent in the database. Any doubts?
No, not it.
Okay. So let me explain now what is the transaction. So how statements are considered as a transaction. So just assume somebody went to an ATM center. So we will discuss about what happens back end of the ATM. Okay. So whenever you insert your ATM card into the that row wherever the port is there. So what happens immediately? First step is user authentication. So we have authentications, right? Windows authentication, SQL authentication. In the same way, it will identify whether you are existing customer or not based on your card number, your PIN code. Okay. So if it authorizes you, if it authenticates you, yes, you are based on your the input details, PIN number and card number. So it finds out if you are authenticated, then we will go to next step. That is, first step is you want to remove, at least you want to withdraw 10,000 rupees. Okay. So first it will check your balance in the account. That means, so it will connect to balance table. So it will check how much balance you have in your table. For example, Hari wants to withdraw 10,000 rupees. So it will go to Hari table. Okay. So it will inquire whether I have sufficient balance or not. So it will start transaction there, begin tran. Okay. So then it will check whether I have the balance or not. If I have the balance, first it will deduct 10,000 rupees from my account. Okay. Then it will update all the log entry. So whenever we deduct 10,000 rupees, we withdraw 10,000 rupees. So before updating to the table, it will update log file. Then it will dispense cash. Then commit happens. So once commit happens, the transaction will be recorded in the database. This is the procedure. Okay. If you see uh, from SQL Server point of view, this is SQL Server, backend SQL Server point of view. So many ATMs uses SQL Server. Okay. So first begin transaction. So it is checking your ID and PIN is exist in the database or not. So it is checking select one from users where user ID is Hari ID, PIN is PIN. So if this statement is satisfies, then transaction commits, you will promote it to further step. If you entered in a wrong PIN, so the transactions will not commit, it will go to here. So okay, then rollback happens. Okay, the message will be shown like authentication failed. So just assume you already authenticated, you are using correct ID and password. So you will be sent to this page. Here, transaction starts from here. First, what you will do, so you are checking the balance. Select account balance, balance from accounts. For example, accounts is the table. So where user ID. So under Hari user ID, what is the balance? It is checking. Then what happens? If account balance is greater than withdrawn, my balance is 1 lakh rupees. So then 10,000 rupees I can easily withdraw without any issue. If my balance is 5,000 rupees, I cannot withdraw 10,000 rupees. So in the same way, it is checking whether my exist balance is greater than withdrawal amount or not. If it is greater than withdrawal amount, so here begin transaction is beginning again, update accounts. My account is updating. So this is backend of the SQL Server. Okay. So this is how transaction completes. So this is a statement, this is a statement, this is a statement, including all
Hari, your
statements.
screen is not visible. I mean, we are able to see that backend transaction small. Yeah,
Okay,
now it is visible. Yeah.
let me share it again.
Think you have to change the settings. Yeah.
Yes. Are you able to see my screen?
Yeah. Yeah.
Okay. So these are individual statements. You need not to remember anything. I'm just showing you how transaction. This is a sample transaction backend of SQL Server in ATMs. Okay. So this is how a group of statements uh, pre-programmed in ATMs. Okay. So the transaction begins here, commits here. So the statements between begin transaction and commit is called as a transaction. Is it clear?
Yes.
Yes.
So a transaction may have single statement also, or may have multiple statements also. Okay. So here you need to remember some properties are there in SQL Server. Not only SQL Server, many databases follows ACID properties, ACID properties we call them. Okay, so any database, if you want to maintain integrity, so that database provider should follow these four properties. Okay, so here I'll explain all four properties first, then we will discuss what is atomicity, how this is relevant to this topic. So we have four properties: atomicity, consistency, isolation, and durability. Atomicity means, okay, so Giri went to withdraw 10,000 rupees from ATM. Okay, so Giri successfully entered his PIN number. It is authenticated. So under option withdraw amount, withdrawal, he entered 10,000 rupees. So whenever he entered 10,000 rupees, immediately he got message like 10,000 rupees deducted from your account. He got the message at the same time, he didn't get any cash. Otherwise, ATM got power off. What happens now? So you get the message 10,000 is withdrawn, but cash hasn't dispensed. Cash has not came out of ATM. What will happen? General thumb rule. What do you know about this? Did you face any issue like this anytime?
Yes.
No.
Okay, what happens in that scenario?
The log, well, it has been logged. That's it. So the cash has been not dispensed, right?
That is fine. Do you get your cash again to your account, or you need to go to bank, or what can you do? So what happens here in normal conditions?
We have to, generally, we have to go to bank.
Nothing needed. Within 24 to 48 hours, your amount will be, if you see immediately, 10,000 deducted will be shown from your account. Automatically within 72 hours, the amount will be credited to your account without any banker person's intervention. Why? Because it follows atomicity. So in a transaction, atomicity means in a transaction means what? Begin tran, between begin
Commit,
tran
right?
and
Commit, right?
commit. Okay. So between these statements, so for example, we have, let's assume 4 statements, 1, 2, 3, 4. First statement is check balance. Second statement is deduct balance. Third statement is, okay, update table. Fourth statement is send cash or dispense cash. Okay, let's assume these are 4 statements. If any of one statement fails, entire transaction should be failed. It is all or nothing. If you want to complete this transaction, you need to pass all these 4 statements. If any one of statement failed, then entire transaction will be rolled back. This concept is called all or nothing concept in SQL Server. This property is called as atomicity. That is why without any user intervention, we are getting our cash back into our account. Is it clear?
Yes, Raj. Means if every transaction is complete, mean every step is completed in the transaction only, then it will.
Yes. See, up to third step completed.
Hmm.
Okay. So
Means if
cash has
any
not
of the
clear.
step has been failed,
Yes.
the complete transaction will fail.
Complete transaction will be failed.
Okay, okay.
If transaction is successful means all statements inside the
Hmm.
transaction should be
Pass.
successful.
Right.
This concept is called as all or nothing.
Okay.
Okay. So this is called atomicity. So SQL Server follows this. If a transaction succeeded means all statements under the transaction got success. If even one statement fails, okay, all steps will be rolled back. Okay. So in the same way, isolation. For example, you want to modify a table. So I have a table. Serial number 1. Okay, name is that. Now, okay, Gaurav is there and Giri is here. So Gaurav wants to make Hari as a Hari Kumar. At the same time, Giri wants to change Hari to Ravi. Can both of them do their operations at the same time? Is it possible? At the same time, can he modify like he wishes, and can Giri think like he can do as per his wish? Do you think
No.
it is possible? No, it is not possible. Why? Because somebody is doing modification to a table. So nobody should touch, I mean, other user should not touch the table until unless the transaction completes. Otherwise, for example, so Gaurav wants to make it Hari Kumar. So whenever he completed KU, immediately Giri came and deleted this, made it Ravi. So after that, Gaurav inquires about table, so he will get result of Ravi, but he is expecting Hari Kumar. So this will be not good for transactions. Database integrity will be lost. So that is why SQL Server maintains isolation. Whenever one user is modifying a table, so temporarily until unless the transaction completes, so the table will be locked. Nobody can touch the table until unless Gaurav completes its transaction. So Gaurav want to make it Hari as a Hari Kumar. Then lock will be released after completing this transaction. Okay, lock will be released. Now Giri can connect, and if he want, he can delete the existing data and update as well. So this concept is called as isolation. An object in the transaction must be isolated when transaction is going on. Is it clear?
Yes.
Okay. So durability. Durability means, so whenever transaction commits, after committing transaction, so even though you lost power, even though you lost your database crashed, okay, the data in the data file must be permanent. So if database crashed, you cannot see the data, but if you are maintaining high availability, okay, so the changed data will be permanent in other database. For example, if you are maintaining second copy, the change is permanent. Once you apply commit, the change is permanent. Okay, that ensures durability. Consistency means a database should, your transaction. So what happens here? Data must be consistent. So before transaction, before commit, after commit. Before commit means transaction is going on. Transaction is under process. Transaction complete. So you can have only two states in the database. One is transaction is going on or transaction completed. Other than these two states, you cannot have any other state. Okay, that tells you about consistency. So your data should be consistent. Either you cannot read your table because transaction is going on, or you can read the table because transaction is complete. That's it. So from these four properties, transaction log file follows, transaction follows all or nothing concept. Okay. So transaction log file is very important in database. Why? Because so whenever disaster happens, we recover exact data based on transaction log file. I'll tell you how. Okay, it is a crucial component of database. All records will be stored in the log file. Okay, so what is the data stored in log file? Log sequence number, LSN number, operation ID, transaction ID. So when the transaction is going on, timestamp, okay, previous LSN, committed or uncommitted transaction, all these details, number of details will be logged. For example, so you are entering a data, simple data. So one, Hari, serial number, name. So how many characters you have entered into the database? 5, right? Here 4, here 1. Is it right?
Yes.
So just assume for demo purpose, just assume this is 5 MB. Okay. If you are inserting 5 MB of data for 5 MB, so this is where this is in data file, actual data storing. For 5 MB of actual data, you can have 100 MB of transaction log file data. Log file. So log file may be updated with 100 MB because so here we are storing not actual data, we are storing metadata. What is metadata? Who is updating? Okay. Transaction committed or not. So when? What is the time? Okay. So which database? So all these are called as metadata, like this transaction ID. So what is the ID of transaction? What is the log sequence number? Where it is stored? So there are multiple things can store in log file. Okay, so you are simply inserting two records here, only two values. For these two values, you need to insert around 100 values in log file. So this means, so you can enter 5 MB in data file, but actually log file will grows very faster. So it might be if you are inserting 1 MB here, you might be inserting 20 MB in log file. Any doubts here?
No.
Okay. So let me show you how transaction log file look like. So here, select star from products. So I am inserting 14th one. So I am inserting how many records here? Okay. So how to see these transactions? So we can use this function select star from function underscore db log null comma null. If you execute this, you can see actual transactions. These are transactions. So what is the last number? Row number?
1784.
1784. Let me insert now a record. We will see what happens. So I am inserting this. So I am not mentioning any begin, run, and commit. Let me show you. I'm executing this. Done. Now check these records. Execute. 1784, right? Now
Yes.
see. So 1784 is here. Okay. So 1785. What is happening here? So we have not
Begin
mentioned
of the
begin tran.
transaction. Mm-hmm.
So we have not mentioned begin tran, but it automatically taken begin. Then it is inserting data. Then it is committing the transaction. So in reality, okay, so you are using only one statement. Here, there are three statements. And what is the data it is capturing? LSN number, operation, context, transaction ID. Okay, so log record. What is the length of log record? Previous LSN number, log reserve, find. Where is the log file? I mean, actual transaction. Okay, so allocation unit name, find. So there are multiple information it will store. Okay, so all this information it stores under one transaction. So I wanted to show you whenever you don't mention begin and commit, automatically SQL Server will do on behalf of you. Is it clear?
Yes, sir.
Okay,
Yes.
done. So database, primary file group, and we discussed data files, extent pages. Now let's come to log file. So whatever the statement you are writing, right? Data entry and modification stores in log file as a log strings. So this insert statement, it is a log string. So it is a log string and this one log string, log strings. So group of log strings called as log record. This is considered as a log record. So this is a string. String means what? Group of characters. This is a string, this is a string, this is a string. And this one is a string, 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 string. Of course, it is integer, but it is considered as a string here in log file. So group of strings is called as a log record. Okay, log records will be stored in log blocks. So group of log blocks is called as virtual log file. Group of virtual log files considered as a log data file. See the architecture of transaction log file. I'll show you. So this is database. It is data file and it is log file. Log file is divided into, just a minute. Log file is divided into VLFs, virtual log files. So VLF1, VLF2, VLF3, VLF4. So this VLF is divided into, okay. So this VLF is divided into log blocks. This is a log block. Okay, this is total VLF. So under VLF, this is a log block. And this is a log block. So under one log block, for example, this is a log block. So this is a log block. So log records will be stored as a here as a rows. Okay. So log records, if you go further, those are called as log strings. Log group of log strings called as log records. Log records stored in log blocks. Log blocks, group of log blocks considered as a VLF. VLF means what? Virtual log file. So multiple virtual log file, a LDF file. Log file is divided into multiple VLF. This is the architecture of log data file, LDF. So there are no pages here, LDF. So unlike data file, so in data file, what is the fundamental storage unit? That is log file. Here fundamental input output unit, we call it as a input IO unit. So if you want to read any information, if you want to insert any information, so fundamental unit here is log block. Is it clear?
Yes.
So remember this thing. So I'll pass two statements. You tell me whether those are true or false. VLFs are equal in size. Is it true or false? What is VLF?
It will basically virtually it will save. It will not save the exact log.
No, actually, physical log file is divided into number of VLF, virtually log file, that is fine. Based on this diagram, is it true or false? VLFs are equal in size.
Yes, equal in size.
Okay, so remember this answer. Then log blocks are equal in size.
No.
Okay, so log blocks are different in size. What is the minimum size of log block? Minimum size of log block is 60 KB. Maximum size of log block, sorry, sir. Minimum size of log block is 512 bytes. Maximum size of log block is 60 kilobytes.
Mhm.
Okay, if you want to increase log block size, so it can be 512 byte aligned. For example, so you have 1024 for, let me show you here. So you have 512 bytes of log block. If you want to increase size, so you can increase in the multiples of 512 only. 1 512, 2 512s. So any number if you give, for example, 512 into 13. So I'll give you 6656. If you divide it by 512, it should give us remainder 0. So you can multiply that 512 into 13 times. So without any reminder, it should divide that number. This is called as 512 byte aligned. Okay. So transaction log file is very important thing of database because whenever crash happens, crash recovery is possible whenever transaction log is intact. So without transaction log file, so we cannot recover all transactions. So we will discuss this topic on restore topic, database backups and restore. So if you want to see the transactions, you can use this command. I already shown you this function. Okay, so let me show you one more time. So this is the function. So if you execute this, this window will come. Output is like this. So here, what is the current LSN number look like? For example, I'll take this number. So what it is telling, there are three parts in LSN number: log, sequence, number. The first part is called as VLF number. For example, this is showing 28, right? Actually, this is not 28. This number is called as hexadecimal number, hexadecimal. So we are following decimal numbers, decimal system. Computer remembers numbers as a hexadecimal. If you convert this, okay, so convert hexadecimal, convert, this number is, decimal number is 40. So VLF number is 40. So what is VLF? So this one is VLF. Okay, so VLF1, VLF2, VLF3, VLF4 like this. So this data is exist. LSN number means what? Where is this data recorded? This data recorded in 40th VLF. And this number is log block number. So which log block it is? Let me copy this. Go to this website. So this is converter, hexadecimal. Convert this, number is 219. So that means under 40th VLF, so under 219 log block, and the sequence is 002. So under second sequence, our data is exist. So this is the number of exact transaction location. Okay. So if you want to see VLFs, how can you see? We have a command that is called dbcc log information info. dbcc means database console command. Execute this. Sorry, I took a new query. Execute this. So this is the file sequence number. So which under which VLF we have our data? 40th VLF. So this is 40th VLF. Is it clear?
Yes.
Just a minute. Okay. So we can see the VLF information, VLF sizes, and this is the file size. See, all are almost equal size, Okay. So this is file sequence number 40, and status 2 means it is inactive. 0 means it is not active. So right now there are 4 VLFs available. 2 VLFs are utilized. Under which database? Under which database?
Gaurav database.
So under Gaurav database, let me open this. How many log files are there?
One.
Two.
So under
Oh, sorry, four log files are there.
how is it 4
That
log files? Can you show me?
here only one
Okay.
minute that VLF.
So this is log file. Actually, I am
Ah,
asking you about log file.
okay.
So log file is one.
Right.
Under log file, we have 4 VLFs.
Okay.
Okay. Under these 4 VLFs, 2 are active, 2 are inactive. Is it clear?
Yes.
Okay. So this is about sequencing number. Now let's come to how information, I mean, how records are stored under VLFs. Okay. So let's assume this is a log file. Under this log file, okay, we have VLFs. It is divided into VLFs. This is VLF 1. This is 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what? LDF. That means log data file. LDF. The log file. So log file is divided into VLFs. So whenever you create a database, there won't be any data in log file first. So whenever start creating any transactions, whenever executing any transactions, then data will be entered, transaction will be entered from first VLF. So for example, you want to insert A, B, C, D, E, F, G. Okay, let's assume each alphabet is a transaction. So first A will be inserted. Okay, then if you want to insert B, B will be inserted here, A will be shifted here, B, A. Okay, then if you want to insert C, these two will be shifted here and you can insert C. So in this scenario, log file grows. If you want to insert D, what happens? So all this data will be shifted here and D will be inserted here. Is it clear?
Yes.
Yes.
So this is called as utilized part. This is unused part. Okay. So whenever you are starting log file, for example, let's assume we have utilized all the log file. Sorry. So whenever you are using, for example, so you have data of G, F, E, D, C, B, A. Okay. So 1, 2, you have this data. So here, whatever you have informed, latest data, right? You entered it. For example, you inserted some data. So apart from this data, this transaction is completed. Whenever this transaction completes, okay, it will marked as unutilized, truncated. So it will truncated automatically. How it truncates, I'll tell you. For example, let's assume these 3 parts already utilized, transaction completed. Whenever transaction completed, okay, so this part is truncated. And here we have never used this part. See, we utilized all these. Okay. Then what happens? So here already transaction completed. Completed transaction part we called it as truncated part. This part is called as unused part. So we have not utilized this VLF yet. The starting position of utilized VLF is called as min LSN. The ending point of utilized part is called as max LSN. The portion between min LSN and max LSN is called as active log. This is the terminology. What is active log? The portion between min LSN and max LSN is called as active log. So active log means the log file is active. The transactions are not committed yet. If transaction is committed, this will be truncated automatically. Is it clear? Then min LSN will be moved here. Any doubts?
So the truncated means that VLF is free, no, for
VLF is free. It is
uh,
truncated. Then some other transaction can use
can
this
use.
VLF.
Okay. Okay.
Okay. So log file will grow sequentially. First, it will grow VLF1 until unless VLF1 completes, it may not go to VLF2. Until unless VLF2 completes, it may not go to VLF3. So it should complete first, then only it will move to VLF4. So it is sequential, not random. Is it clear?
Yes.
Okay.
Yes.
So whenever VLF is completely occupied, for example, let's see this. Whenever VLF completely occupies, okay. So it will again from here, VLF10, right? So from VLF10, it will try to move VLF1. Let me show you here. It is from here. Done. For example, this is completely utilized. Whenever this one completed, let's assume this one freed. So whenever this one freed, so from here, it will again, okay, sorry. I'll take shapes, insert shapes, take this one. From here, it will again come to first cell. This is called as wraparound. Table layout, table design, all borders. So whenever 1, 2, 3, 4, 5, 6, 7, let's assume we have 7 VLF. Whenever seventh one fills, okay, it will try to wrap around to first one. So it will check whether first one is free or not. If it is free, then it will utilize first one. There is no need transaction commits in sequentially. For example, transaction might be committed here also. Transaction might be committed here also. Okay, then so it will wrap around after completing of seventh one, VLF7 completed. So now it come to VLF1 first, utilizes here. That means utilizes here. Then whatever the empty part, truncated part, utilizes this one also. Now this one also. So wherever truncated part is available, it will try to utilize all the empty parts. This is how transaction log file filling goes on. Is it clear?
Yes.
Yes.
Okay. So this is a transaction log file. This just consider this one as a physical log file, physical transaction log file. This is physical transaction log. Okay. So log file is filled up to here. This is considered as a logical log file. So the yellow color one, whatever I am showing, is considered as a logical log file. Because logical log file, so whatever is utilized, we consider it as a logical log file. And physical log file is considered what? The thick part from cell E14 to cell N14. This entire thing is considered as a physical log. Now I'll tell you one some terminology. Let's follow. So whenever logical log meets the end of physical log, wraparound happens. Is it true? So this is log file, right? Log file, logical log file. So whenever logical log file meets end of the physical log file, what is the end of physical log file? What is the end of physical log file?
N14, at N14.
Yeah, here it is end of the physical log file.
Mm-hmm.
If logical log file meets physical log file, that means it is completely filling.
Mm-hmm.
What happens? It will try to
Wraparound.
wrap around. It will try to come here to here. So this is considered as whenever logical log meets physical log, a wraparound happens. I'll tell you one more thing. So for example, here it is, this part is already truncated. I mean transaction, before it is completing, transaction is committed. Let's assume like that. And here also, here also. So whenever it is filling, in the same way, here also transactions committed and transactions committed, and these parts, this VLFs truncated. Now what happens? Wraparound happens, right? So whenever logical log meted physical log, wraparound happens. So VLF1 is empty, then it will try to utilize this part, right? Isn't it?
Yes.
Then next, what happens? It is full, then it will utilize what? This VLF. Okay, now what is the physical logical log file beginning point? This is logical log beginning point. And logical log ending point, what? This is logical log ending point. Isn't it? Any doubts here?
No.
No.
If you are facing any confusion here, let me explain one more time or ask me one more time. So this is the starting point of logical log because logical log starting from here. This is the end point of logical log because logical log is ending here. So still this ending point and starting point not met because there is a gap. So you can use one more VLM. Is it clear?
Yes.
Yes.
Yes. So in the same scenario, let's assume. So this is logical point, logical log end point. This is logical log starting point. So this part also it is utilized. Means what? So logical log end point met logical log start point. In this scenario, we consider it as a log file full. So this entire log file is full. We can say it whenever logical log, end of the logical log meets starting point of the logical log. We can consider it as a log file full. Is it clear?
Yes.
Yes.
So these are VLFs. VLF when it is completely filled. After that, when transaction completed, this utilized part truncated. So starting point of logical log is called as min LSN. Ending point of logical log called as max LSN. Between min LSN and max LSN, we call it as active log. This is unutilized part. So if we have multiple log files, okay, before going to that, let's discuss this. I already explained this. Whenever end of the logical log meets end of the physical log from here to here, a wraparound happens. Okay, so whenever end of the logical log meets end of the physical log, wraparound happens. Whenever end of the logical log meets beginning of the logical log, then we consider it as log file full. Any doubts here?
No.
Okay, so if you have multiple log files, okay, so it starts growing like this. So it will starts from here to here, 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 here. It will fill like this. Then after completing first log file, it will go to second one, starting point of second one. Then after completing second log file only, it will move to third file. After completing third file, it will again move to first file. Okay, so if it is able to utilize the same file multiple times, there is no need of creating other log files. This is a statement. Do you agree with me? For example, this is a log file. Okay, so it is growing like this. After growing to certain part, here some transactions are committed. Then again, it can utilize this part also. So if a log file is able to utilize same VLF portions again and again, there is no need of creating multiple log files. Even though you create, for example, even though you create, until unless it's completely filled, you cannot utilize this one. Until unless completely filled, you cannot utilize this one. Even though you have multiple log files, so you cannot utilize them until unless these files getting filled. So why should we waste with log file or multiple log file size? So you can maintain a single log file. Okay. So for example, you want to create 4 log files of 1 GB. Why are you creating 4 log files of 1 GB? Let's make it 4 GB single log file. So that 4 GB is completely utilized. If it is utilized 4 GB, then whenever transaction commits, that empty parts, truncated part, it again can utilize. So there is no need of creating multiple files. Okay, single log file is enough for most of the environments. If your environment is demanding more, maximum you can create 2 to 3 log files, nothing more than that. If you see, for example, in your future, if you go to some other company, you find 10 log files there, that is a blunder. We should only maintain 1 log file, maximum 2. More than that, if they are maintaining log files, that is not perfect architecture of database. Any doubts?
No.
Okay. So up to now, I was telling you whenever transaction completes, right, the part is truncated. So who truncates this part? Now that will start as a checkpoint. Checkpoint is a command. So whenever checkpoint occurs, what happens? All the committed transactions are marked for truncation. For example, this is the log file. So here transaction A started, B, C, D, E, F, G, H, I, J. So meanwhile, whenever J transaction is completing under VLFO, so VLFJ transaction completed. So whenever it completes checkpoint, what happens? It will not truncate actually. Checkpoint will write it as a, mark it as a rewrite. Marks it as a rewritable. That means, for example, it will mark like this. So what is the meaning of this color is, so if your log file is completed, I mean full, you can utilize this J part. So for example, J completed, I want to enter H, then I can enter H here. I can rewrite this information. So what checkpoint will do? Checkpoint will mark like this. So here should be I, here should be E, here should be C. So checkpoint will not truncate anything. Checkpoint will mark VLFs as it is completed, transaction completed. It is ready for rewriting. Okay, so J completed. Now I want to enter H transaction. I can enter H here. Then it is full. So whenever, then here I can use, then here I can use. So in this manner, whenever transaction completes, checkpoint will note it down as a completed transaction and it marks for truncation. After some time, one more process will be triggered. It is a system process. We call it as a lazy writer. Lazy writer clears each and every completed transaction. So this is marked for rewrite, right? So lazy writer goes here. It will clear. It will clear. So there are two processes. One is checkpoint and lazy. Second is lazy writer. So before clearing, what checkpoint does? Checkpoint every 60 seconds, 1 minute. For every 1 minute, it will occur. For every 1 minute, what it will do is, it will, whatever the committed transactions, for example, E is committed, right? So it will write E to data file. Let's assume this is a data file. So this is a data file and this is a log file. So we discussed this, right? Until unless commit happens, the data cannot be permanently changed in data file. So whenever commit happens, so this E will be written here. Whenever commit happens here, this I will be written here. I will be written here. But it is not removed from here. When it removes, whenever lazy writer triggers, then it will be removed from transaction log file. So there are two terminologies. One is checkpoint. So it is an event that flashes dirty pages. What is dirty pages? So we are talking about this multiple times. I'll keep on asking you the same question. So something happens in computer, where it happens. Who is the doer? Who is the background person doing all your activity in computer?
Service.
CPU, processor. Processor will do all the calculation. Processor will do all the IO work. Processor is the man behind doing all the activities. Okay. To perform all the activities, he needs some space. What is the space?
Memory.
Memory. Very good. RAM, memory. So all operations takes place in RAM. So RAM, we call it as a buffer. Okay. So for example, you have a page. Let's assume this is a page. Under page, we have some data. Hurry. If you want to modify this page, page is where? Page is under data file. You cannot directly change page in data file. That page should bring to buffer. Here in buffer, you can modify this Hari as a Ravi. Okay. So then whenever checkpoint happens, this Ravi will be write it down here. Okay, whenever lazy writer triggers, then Ravi will be clear. Is it clear? This is the order.
So that checkpoint moves the data from
Yes,
buffer to data
yes,
file.
yes, very good. Good observation. Whenever checkpoint triggers, it will move all the modified pages in the buffer pool to
Okay,
data.
data file.
Okay, this is Hari. This is in data file. So I want to change Hari as a Ravi. First, what I will do, entire page, I'll bring it to buffer. Under buffer, I'll rename it Hari as a Ravi. Then whenever checkpoint triggers, this data will be returned to disk.
And
Is it
lazy
clear?
writer will clear the buffer data.
Yes, lazy writer will clear each and everything, modified
Okay.
pages.
Okay. Fine.
Is it clear?
Yes.
But whenever transaction commits now, so you can rewrite this information, even though lazy writer is not committed, not triggered or not triggered. So until that, you are free to utilize this space because
Right.
checkpoint already triggered. Whenever checkpoint triggers, it will be marked as rewritable.
Right.
Is it clear?
Yes.
Okay. So now let me know. This is Hari, right? I bring back this information here. So where is this information? Under buffer, right?
Mm-hmm.
So is it modified yet or not?
Not yet.
So unmodified pages in buffer pool is called as clean page. If I modify this page, Ravi, okay, this page is modified or not?
Yes.
Modified pages in buffer pool is called as dirty pages.
Okay.
Dirty page means what? Modified
Means
pages in buffer pool.
modified but not committed. Like this or
Committed or uncommitted. If it is
okay.
modified, it is
Okay.
still in buffer. It is
Mhm.
modified. It is still in buffer pool. That is
Right.
called as dirty page. So can I say like this? Whenever checkpoint triggers, dirty pages will be moved to data file.
Yes, we can.
Yes.
Okay. So that is the thing. Dirty pages that have been modified but not yet returned to disk. Okay. So whenever checkpoint triggers, okay, it flashes dirty pages from buffer cache to disk. Any doubts here?
No.
So when checkpoint triggers, so there are multiple scenarios checkpoint triggers. So by default, every 1 minute it will be triggered. How can you control that? Go to your SQL server, go to instance, right click, go to properties, go to advanced, security advanced. I think not here. Checkpoint value under database settings. Go to database settings. So this is recovery interval. If you are mentioning 0, that means by default it is taking 1. If you want to change, you can change it to 2 or 3 or 4. But it is not recommended. Larger values not recommended. At least 1 is fine because for every 1 minute, all the changes should be committed. All the committed changes should be written to disk. If you don't write to disk, that change will not be permanent. If something happens, power down, or something database crash, or something happened to data disk, so the changes won't be permanent. So every 60 seconds, checkpoint will be triggered. Whenever checkpoint triggers, dirty pages return to disk. Okay, this is the recovery interval. So this setting you can change database level also. So this is instance level setting. Instance level setting. Go to database level, right click, properties. Go to options. target recovery time, 60 seconds. If you want to change it, you can change it to 30 also. So database level, you can change this setting. Okay, this is called as checkpoint. If you don't mention anything, by default, every 60 seconds, it will be triggered. Okay, that is one scenario. Whenever you take log backup, it will be triggered. So if you, what is log backup, we will see in future. So whenever you take transaction log backup, checkpoint will be triggered. Whenever database is in simple recovery model, okay. So if it is in simple recovery model, every 60 seconds it will be triggered. Whenever you add a new data file, so your data file is not sufficient, you are adding one more NDF, then checkpoint will be triggered. Whenever you shut down database, before shutting down, so checkpoint will be triggered. All the modified pages will be returned to disk, then only database get shut down. What it does, so whenever checkpoint triggers, it will mark all committed transactions for overwrite. It requires some information, last checkpoint LS and previous checkpoint LS. So what is the date and time, all these details. So it may invoke lazy writer. Sometimes it will invoke lazy writer, and there are other scenarios where lazy writer invokes. This is not actual diagram. So I'm showing like this. Lazy writer means it is a background process. So it will flushes dirty pages to disk. It is also flushes dirty pages to disk, but it will clear all buffer memory. So if your buffer pool is 80% full, it will trigger, it will clear all the committed transactions. Okay. So clean pages, unmodified pages, dirty pages, modified pages, and buffer pool. So checkpoint is triggered for every 60 seconds. So whenever checkpoint happens, dirty pages move to disk. Lazy writer flashes both dirty pages and clean pages. Here checkpoint flashes only dirty pages. Lazy writer don't think about any page. If the page is exists in buffer pool and it is committed, it will flash everything. So the main goal of lazy writer is making buffer pool memory available. If buffer pool is full, lazy writer will trigger. It will clears memory for buffer. Whenever RAM is full, so it will trigger and it will clears the RAM memory. So checkpoint goal is not clearing the buffer. Checkpoint goal is making transactions permanent. Any doubts?
No.
Okay, fine. So we'll stop from here. A beautiful concept is there, VLF calculation. So tomorrow we will see how to calculate VLFs and how to maintain VLF count. Okay, let me stop from here.